What's up, everybody? Welcome back. Today, looking at working bevels, a little bit of transference from blueprints, maybe thinking about expanding our knowledge on ratios. That is because working bevels is just building off of our previous knowledge of ratios. That's good news. We already know how to do this. We just need to understand how to apply it because it is just a ratio. Okay, so working bevels, we're looking at key terms. First of all, for working bevels, the slope, the rise, and the run of what we're looking at on a drawing. Working bevels will always be shown as something like this, rise over run, or the slope of whatever we're looking at. Maybe it's a stairway, maybe it's a ramp for wheelchair access, maybe it's a slope for a driveway to access the outside of a building. I'm not sure what it might be used for. There's a number of different things. So we'll look on the blueprint and it's going to show us a working bevel, or it's a fabrication drawing and it's going to show us a working bevel, or it's a detail sheet for a stairway and it shows a working bevel. So that allows the architect or the engineer to just eliminate a whole bunch of information and simplify the drawing. Rise over run is the key for what we're looking at here. If you can remember rise over run, doing these ratios becomes very simple because it's telling us which number goes where all the time. If you always do rise over run, it becomes simple to do your problems. Another thing that you're looking at that you're going to see for working bevel is ratio. I said it's just another way of doing ratio, and there it is. In this case, our ratio is a scale. So you should be at this point familiar with blueprints. On a blueprint, you get a scale for how big the drawing is versus how big the job site is. For example, on a construction drawing, it might say 1 to 12. So every 1 inch on a drawing represents 12 inches in real life or something like that. So in this case, we have scale. If our scale is given at a ratio of 250 or a ratio of 12 inches, what we need to recognize here is that 250 or 12 inches is always going to be our biggest number. Okay, so if we're looking at a triangle and we don't have a side, we're missing a side, and we just have this number floating over here, we're not sure where it goes. Remember that if this is the longer side, if your run is longer, that 250 represents the run. If your rise is longer, that 250 represents the rise. Okay, so your larger number will always be a 250, or if it's in imperial, the longer side will always be represented by 12 inches. Okay, there's no inches or no feet, there's no millimeters or there's no meters. You could make 250 millimeters or meters or 12 inches or feet. We're just going to leave it as open to understand that the bigger number is going to be metric, the smaller number is going to be imperial. Okay, so we know rise over run is something we're gonna hold on to. That's going to be helpful to us, and we're also going to remember that the number given, either 250 or 12, is always going to represent the bigger portion of rise over run. Okay, and if we're doing a slope for a stairway or anything on a job site, driveway, a wheelchair access, what you need to realize is that if your run is shorter than your rise, you have a very steep slope, which would be a bad thing, right? If my run is very short, and my rise is very tall, I am increasing the slope. That's going to be hard to get a wheelchair. Or if you're, excuse me, you go from a stairway to a ladder pretty quickly if you start messing with that. So what you're thinking about is not only is the bigger number always representative of 250 or 12, but chances are your bigger number is going to be the run as well on a job site. Most of the time, not always, but a lot of the time. Okay, so what we're thinking about now is, where do these numbers go? What do we have? We have 250 on the left and 250 on the right. Well, what does that mean? If we think about this as this is our run, and this is our rise. So run is the length of your slope, and rise is the height of your slope. And we're thinking as 250 is always the longer number. So in this case, your run goes here and your rise goes here. In the other number, this is still your run and your rise is over here. So what does that change? If you keep it the same, it doesn't change anything. So let's draw it out. Remember, if in doubt, draw it out. So let's go ahead. Now I can mess up my drawing and make some markings. So if I've got 250 and I turn it into a ratio, I don't know what 250, what the other side of this ratio is. The little line is a blank. It's a question mark. I don't know what that is, but I do know, because I already mentioned it, is that the 250 is always the longest side. So that means I can just put down below the 250, 6,700. And if that's the other side, that means that's the run. The rise is 42.50. Okay. So right now this looks a little confusing. You're like, well, how does this turn into math? How do I math this thing and come up with an answer for what's the other side of 250? And the answer there is rise over run. Remember in that last slide, I said, always put rise over run. It'll just be easier to remember. So that's what we're going to do now. We're going to do rise. So which one is the rise? And remember at the beginning, I said the rise is there and the run is here. Run is the length and rise is the height of your slope. So going back to my math, creating an equation, I have a rise of 42.50. And I have a run of 6,700. So now I've put rise over run. And I'm going to put that is equal to 250 question mark. 250 is always the same as my long leg. So it goes on the bottom, right? The rule of ratios always match which side you're putting them against. So the 250 we know is the run, the longer side. So I have to put it on the bottom where its friend 67, the 100, the long side is. So those match. So now it's a simple matter of cross multiplying and dividing. If you forget ratios, go back to look at math from level 1 and review your ratio problems or ask a tutor for help. But in ratios, we're going to cross multiply and divide. That means I go across to multiply, and then I'm going to divide on my way down to the 6,700. So I do 250 times 42.50. I get an answer, and then I divide that answer by 6,700. So I cross multiply and divide. And that's what that looks like if I need to. Don't forget the equal sign. You might end up, because of bad math, getting a funky answer when you do these things switched around. 250 times 42.50, which gives us a massive number, divided by 6,700 equals 158.582, and so on. It goes a whole bunch of decimals. So 250 is the same as saying 159, because I'm just going to round to the nearest millimeter there, okay? This other direction is going to be the same answer. Now you can go and do it the other way, and you'll just discover that you end up with the exact same number. So if you do rise over run and you cross multiply and divide, it doesn't matter which side of the ratio the 250 is on. You're going to end up with the same number because 250 is the long side. That means that the number beside 250 will always be smaller than 250. If you do the math and you get a number bigger than 250, you boo-booed. You've made a mistake. 250 is always your long side, okay? Or 12 inches if we're dealing with imperial. So then we've got, this is more of a standard working bevel scenario. This is a little bit more typical to what it looks like. Your engineer is giving you your scale on a smaller triangle, your actual working bevel. So when we say working bevel, this is typically what we're looking for on a drawing. And then we can relate it to a bigger part of the drawing that it's attached to, in this case, 1200. So we need to know what's the rise of this scenario, right? So we've got the run is 1200 and the rise is I don't know what, but I'm given my working bevel of 250 run and 188 rise. Okay, so I'm going to just go ahead and put that into an equation. Rise over run. In this case, it's a rise of 188 over a run of 250. And that's equal to a rise of I don't know what and a run of 1200. Okay, so my run matches. I've got a run of 1200 here and I've got a run of 250 here. I've got a rise with a question mark here and I've got a rise with a 188 here, right? So now I can just go ahead and cross multiply, and then divide. And I'll draw it out for you just to make it clear what exactly I'm going to do. 1200 times 188. Then I'm going to say equals divided by 250. And that's going to tell me what that question mark is. Okay, it's going to tell me what that is. So then I know how far it is across and how high it is. If I need to build the thing, how tall do I have to make it to reach that same rise to run? That working bevel transfers then exactly. So 1200, cross multiply and divide, and we get 902.4 millimeters. Okay, so if I go 1200 long, I need to go 902 high at that working bevel. That essentially is it. So rise over run, and the 250 or the 12 always represents your long number. If you can remember those two little things, all we're doing is moving ratios around. Pretty simple stuff. Okay, so go back and review your ratios if you haven't, and then have a crack at the worksheets and see what you come up with. All right. I hope this was helpful. Enjoy the rest of your time working on this, and all the best to you.